Okay, hi everyone. So we have another video. So this is a very short one, and hopefully this will just introduce to you the redox topic. So let me just open my PowerPoint. So it's redox. So it's basically part of your week 3 and 4 module. So I'll just be talking about what redox is. Basically, this is a very short video just to discuss to you the concept of redox, just not to confuse what is oxidation versus reduction. So as defined, when we talk about redox, it's actually oxidation reduction. It's not reduction oxidation. It's called redox, but technically it's oxidation reduction. So there are two processes involved. One is oxidation and the other one is reduction. And when a substance is oxidized, it actually loses electrons. And when it's reduced, it gains electrons. That's where a little confusing maybe for to well, if it's just your first time to encounter it, please don't be confused with my pointer. So again, you might be confused. It's gaining, but it's the reduced substance. Yes, the reduced substance actually is the one gaining the electron. And of course, the oxidized substance will be the one that lost the electrons. When we're talking about electrons, you know very well that will be the negative subatomic particle. Again, you have three. We have your neutron, your proton, and your electron. Electron is the one at the outer orbit, which is the charge is negative. It's the lightest of all among the three subatomic particles. So in an oxidation reduction reaction, you're actually observing the behavior of that electron and how it affects substances. Okay, our symbol for electron, we will be using it moving forward is E negative. So when you lose electrons, of course, the substance become more positive. When it gains electrons, the substance uh, becomes more negative, and that affects the oxidation number. That's why for most of the time for oxidation number, you can see that they're positive, meaning those oxidation numbers uh, describe the material as it become more positive or as it loses electrons. Okay, this is just again graphically speaking. If we're talking about the behavior of your atoms or molecules or ions, so oxidation is again electron loss and reduction is electron gain. A very specific example is your aluminum and copper. When you submerge your aluminum to a copper solution, copper chlorine solution. So you can see from the first picture that will be aluminum submerging it to this copper solution. After a few minutes, you begin to observe that your aluminum becomes different. I mean, physically, it becomes different. There becomes a brownish maroon um, coating to it, which is, of course, very similar to our rust, the rust you see in our iron metals. Okay, so you can see also another observable difference will be the color of the solution from blue becomes, of course, colorless. So if you were doing this inside the laboratory, I would actually check two observations. You have to observe the aluminum as well as the copper. Okay, observable indicators will be the aluminum change in appearance by changing its color. From silver, there's a brownish maroon coating to it, as well as your copper solution. From blue, it becomes, of course, colorless. So this is the specifics of that. And if you want to see it in equation form, but this is a different reaction. This is cesium and fluorine. So just to distinguish what oxidation and reduction is, if you're given this complete reaction, you have to identify which is oxidized and which is reduced. Of course, cesium is the one oxidized because it's the one that lost the electron, And fluorine will be the one that is reduced because it's the one that gained electrons. Okay, see it here. Because your end product here will be a fluoride ions, which has a negative oxidation number. So it's the one that's reduced because it gained electrons. And I think this is my last slide for this. I told you, just really a short module, just to give you some ideas on the behavior of electrons, hydrogen, oxygen, and the effect in oxidation number when it's either oxidation and reduction. Okay, on my take, these are the two major processes. First, of course, we defined it earlier in the first few slides via electrons. So that's where I would remember it. That's where I will remember what oxidation is. It's actually losing electrons. So when you lose electrons, it follows also you observe your hydrogen, you also lose hydrogen. Counterpart on the reduction process, we said that when it's reduction, you gain electrons and you don't lose hydrogen. Instead, you combine with hydrogen. So again, I want to remember it's given as a descriptive. It's descriptive in the problem. It's not stated if it's oxidation or reduction. These are things or characteristics that you can check. And next would be, what about after checking electrons, hydrogen, check oxygen. In most of the problems that I have encountered, I can see that it behaves the opposite. If you're losing hydrogen, you're combining with oxygen. If you're gaining or combining with hydrogen, you're losing oxygen. And finally, of course, well, this is very consistent. It's oxidation. That's why there's an increase in oxidation number, or meaning that compound or that substance has actually a positive oxidation number. And of course, when it's reduction, there's a decrease in oxidation number. Not necessarily it's always negative. It's just that the oxidation number could be lower because there's actually a decrease. Okay. For now, I'll stop at this slide. I'll have the next one, meaning I'll be applying some of the concepts here to the next module, which is balancing redox reactions. Okay, so please, if there should be questions, there's a messenger box, there's a discussion box in Canvas. You can also PM me or PM our group chats in Messenger. Or once this is posted on our FB group, you can actually comment your questions or feedback. Okay, so for now, I'll be leaving you with this module or this video, and let's go to the next one. See you. Bye bye.